So we want to calculate electric field at the point C. So we have two charges. So both charges they have some contribution at the point C. Electric field contribution. So due to the positive charge, the electric field at the point C it's going to be away from the charge. I just name it here E1. And then due to the negative charge, it's going to be toward the charge. This is negative, okay? E2. Obviously if you think about it right now, so E1 has a component, okay? So I mean the best thing you can do, you can draw the free body diagram at the point basically C. So as you can see, so let's assume here this is E2 and then this is E1. Obviously E1 has a component, okay? I just named this one E1 X and this is E1 Y. Same thing for the E2. So how is E2 X and then this is E2 Y. And obviously you see the electric field along the y-axis is going to be 0 because first of all the Q1 and Q2 are same, okay? So they have the same magnitude, okay? And the distance from the positive charge until the point and is same as the distance from the negative charge until the point. So E1y will cancel E2y because they're opposite direction, okay? So basically what you can say from symmetry, electric field along y is 0. I mean what you could do, you could go and compute the E1y and E2y, but then the electric field along the y-axis becomes 0 because they are going to cancel each other, opposite directions, and they will actually they will cancel each other. Okay, so there is no electric field along the y. So what I will do, I will try to calculate electric field along the x-axis only. And if you find E1x is enough, by the way. This is high x, because if you find E1x, if you multiply the E2x is same as E1x because Kelche is same, the distance, everything is same, okay? So I need to find what they call E1x, okay, which is, if you think about it here, I will just try here draw a line just to make it in a proper form. And now we know from symmetric that the angle here is same as the angle here. So if here now is alpha, here is alpha also, okay? So I need to find the alpha, I need this angle, okay? Because in the end E1x is equal to E1 cosine alpha, بس نحن نحتاج alpha obviously, okay? You need to get alpha somehow, and to get alpha is a bit math you need to understand, okay? See what I'm going to do. What I will do, okay, I will say this point is in the middle, exactly in the middle, okay? So this is going to be the right triangle. So you see over here, I'm just drawing it over here. So I know that I don't know what is the length over here, I need to calculate, but I know that here is going to be, the point C is exactly in the middle. So the total here is 10, so therefore here become 5 centimeter. I hope you understand. And here is 13 centimeter. And obviously by Pythagoras you can even find this one, but مو بلازم. I want only to find this angle alpha, okay? And to find alpha, what I can do, I can say I will say cosine alpha is equal to adjacent, which is 5 over hypotenuse 13. So therefore you can say alpha is equal to, so you use cosine inverse obviously, and cosine inverse of 5 over 13 is going to be equal to 67.3 degree. So we got this information, okay? So we have here the angle. Let me just, okay, we got the angles, okay? Now I want to compute the electric field along the x-axis, yes, and E1x is equal to E1 cosine alpha. Okay, and then E1 we know that is equal to K Q1 over distance. What's the distance from the point until the charge, which is 13 centimeter? So it's 0.3 square cosine alpha, cosine 67.3, and I know that K is equal to 9 times 10 to the power of 9, and Q1 we know it is 12 minus 9 over 0.13 square cosine. Now let me calculate it height, and you're going to get equal to 9 times 10 to the power of 9, 0.13 square, then multiplied by cosine 67.3. I got it, it's a very small number, it's whatever it is. I got it 2.055 times 10 to the power of 11 newtons per coulombs. Okay, this is E1 x, but this is not yet the final one. Okay, total electric field along x at point C is equal to E1x plus E2x, but E1x and E2x are identical, because E2x is due to the other charge, but the other charge and the distance calculation is same. So basically what I can do, I can just say 2 E1x. So you just multiply it by 2, you're going to get 4.11 times 10 to the power of 11 newtons per coulombs. Okay, and then finally, okay, electric field at the point C, there is no y component because they were cancelling each other, so it's equal to only the total electric field along the x-axis, which is 4.11 times 10 to the power of 11. Sometimes they write it I, vectors. So this is the answers.